My name is Harrison York, and my project is running form analysis. The motivation for this project is that I began training for a long-distance run this semester, but didn't have a clear idea of what proper running form was. It was also difficult to evaluate my own running form while I was running. The solution I have is a machine learning project to analyze running form and provide feedback based on key errors that are common among beginners. This project uses a YOLO model for pose estimation. The YOLO family of models are excellent for object detection and image segmentation, and are easily accessible with a wealth of documentation. The model processes images in a single pass to detect bounding boxes and classes, which allows it to operate with minimal latency for videos. This also gives the model its name, You Only Look Once, as this approach to object detection differed from previous methods when the model was released. The model is developed extensively by Ultralytics. In a pose estimation application, the model creates a bounding box around the person and estimates 17 different joint locations. The coordinates of predicted joints and the bounding box are available in the output. The next step in the form analysis pipeline is to interpret pose estimates and identify form errors. This is done with a new model designed and trained by me. It takes key point data as input and outputs the probability of each form error being present. The model is a one-dimensional convolutional neural network which leverages the time locality of joint positions to identify form errors. One problem, however, is that there isn't labeled running form data available. As a result, I manually recorded about 150 videos of me running, with various errors as well as with proper running form. For this project, I'll focus on heel striking, leaning too far forward, holding arms too tight, and swinging arms too loosely. The key point data from the videos will be used to train the form analysis model and produce the probability of each form error being present. Next, I'll go over the project architecture. The athlete pose dataset is a collection of tens of thousands of images and key points of people doing running, figure skating, and track and field motions. This is essential because the key point positions are the ground truth labels needed to fine-tune the YOLO model. The YOLO model is fine-tuned on the data, which alters model parameters in the final layers. This allows the model to better estimate poses for running. The fine-tuned YOLO model can then take an image or video and estimate a runner's pose. In addition to the overlay of the pose on the original video, the output includes the key point data. To get a lot of key point data for training, I passed all of the running form dataset videos through the fine-tuned model and collected the key point outputs. Then I added a small amount of noise to the key points, which allowed me to duplicate the original data with jitter. The key point data is then split into training, validation, and test sets. The training data is used to train the form analysis model, which learns a representation of different error types as a function of the key point inputs. The model outputs a probability for each error type being present, which informs the user whether they are making mistakes with their running form. Alright, now for a quick demo. I'll upload a video. For this, I'll do arms loose. The website shows you a preview of your original uploaded video, and here you can see that my arm is very loose down by my side. I'll click Analyze Form, and now the video is going through the pipeline of pose estimation and then form analysis with the two different models. We can see that the form analysis tells us there's high confidence that our arms are too loose, and if we play the video again, we can see that the joint overlay shows the loose arms that we predict. For another demo, I'll choose heel strike. With this, you can see that my heel hits the ground before the rest of my foot, which is bad form. We'll run the analysis again. This is going through the same pipeline of pose estimation and then form analysis, except we expect heel strike to have high confidence. The model outputs what we expect. And if we play the video, again we see the joint overlay.